In this lesson, we will take an introductory look at questions concerned with motion. To begin, motion questions involve three basic elements: distance, rate, and time. Now, distance can be measured in miles, kilometers, feet, meters, and so on. Rate, also known as speed, is measured in units of distance per unit of time, such as miles per hour and meters per second. Finally, time can be measured in hours, seconds, days, and minutes, to name a few. Now, to tackle motion questions, you must be familiar with these three formulas that relate the three common elements of motion. Let's apply each formula to a different scenario. For example, let's say that a bird travels at a rate of 30 miles per hour for 5 hours. To determine the distance it traveled, we multiply the rate of 30 miles per hour by 5, the number of hours traveled, to get 150 miles. For the next formula, consider a glacier that travels 75 meters over a time of 25 years. To determine the glacier's speed, or rate of motion, we take the distance of 75 meters and divide it by the time of 25 years to get a speed of 3 meters per year. For the last formula, let's say that an asteroid is traveling 10 kilometers per second and it is 800 kilometers away from some planet. To determine the time it will take for the asteroid to reach the planet, we take the distance of 800 kilometers and divide it by its speed of 10 kilometers per second to get a time of 80 seconds until the asteroid reaches the planet. Now, while these three formulas are important to know, we can memorize all three of them by memorizing this one fraction, or even this abbreviated one. All three of the motion formulas are contained within this one fraction, and here's how it works. Let's say we want to know the formula for distance. All we do is remove the distance from the fraction, and whatever is left is equal to the distance. So here the distance is equal to the rate multiplied by the time. Similarly, if we want to know the formula for rate, or speed, we remove the rate from the fraction, and whatever is left is equal to the rate. So here we can see that the rate is equal to the distance divided by the time. Finally, to find the formula for time, we remove time from the fraction, and whatever is left must be equal to time. Now, it's important to note that before we apply each of these formulas, there are certain units of measurement that must match first. Let's begin with the distance formula. Let's say that some object is moving at a rate of 10 miles per minute, and we want to find the distance the object will travel in 5 minutes. The distance formula tells us to multiply the rate by the time. However, before we do this, we must first confirm that the time units match. Here, the rate is measured in miles per minute, and the time is measured in minutes. Since the time units match here, we can determine the distance the object will travel by multiplying 10 by 5 to get 50. Now, what are the units of measurement for this output? Well, when we apply the distance formula, the output is measured in the distance units found in the rate. So for this example, the rate is measured in miles per minute, which means the distance units are in miles. Subsequently, the output will be in miles, so the object will travel 50 miles. Now, the requirement for matching units is pretty much the same for the time formula. Let's say that we want to know the time it takes for an object to travel 24 meters if that object is moving at a rate of 3 meters per millisecond. The time formula tells us to divide the distance by the speed. However, before we do this, we must first confirm that the distance units match. Since the distance units do match here, we can find the time by dividing 24 by 3 to get 8. Now, what are the units of measurement for this output? Well, when we apply the time formula, the output is measured in the time units found in the rate. Since the rate is measured in meters per millisecond, the output will be measured in milliseconds. So the object will take 8 milliseconds to travel 24 meters. Now let's see what happens when we apply the rate formula. Let's say that some object travels 40 inches in 2 years, and we want to find its rate of motion, or speed. Well, the rate formula tells us to divide the distance by the time, and when we apply this formula, any units can be used. So to find the rate here, we will divide 40 by 2 to get 20. Now, what are the units of measurement for this output? Well, when we apply the rate formula, the output is measured in the distance units per time unit. So in this example, the distance is measured in inches, and the time is measured in years. So our subsequent rate will be measured in inches per year. Now, as we have seen, the distance formula and time formula require some matching units before we can perform any calculations. So if the required units do not match, we must perform some kind of conversion before calculating. Take the following question. Here we are told that a meteor is traveling at a speed of 180 kilometers per minute, and we want to determine how many meters the meteor will travel in 7 seconds. Since we are trying to find the distance traveled, we will apply the distance formula. However, before we can apply this formula, we must first have matching time units. At the moment, the rate is measured in kilometers per minute, and the time is measured in seconds. So to ensure that we have matching time units here, we can either convert the minutes into seconds, or we can convert the seconds into minutes. Since it is easier to convert minutes into seconds, let's do that. To do this, first think of the rate as being 180 kilometers per 1 minute. Since 60 seconds are equal to 1 minute, we can replace 1 minute with 60 seconds to get a new rate of 180 kilometers per 60 seconds. Now we want to convert this rate into a unit rate. In other words, we want to express the rate in kilometers per second, not kilometers per 60 seconds. So let's apply the rate formula, which says to divide the distance by the time. Well, as it stands now, the information here is telling us that the meteor can travel 180 kilometers in 60 seconds. So to turn this into a unit rate, we divide 180 kilometers by 60 seconds to get a rate of 3 kilometers per second. Now let's take our converted speed, move it up here, and add the given time. At this point, the time units match, so we can now apply the distance formula. The distance will equal 3 times 7, which is 21. Now we already learned that the output will be measured in the distance units found in the rate. So since the rate is measured in kilometers per second, the output here will be in kilometers. So the meteor will travel a distance of 21 kilometers in 7 seconds. Now the question asks us to determine the number of meters the meteor will travel. So we still need to convert 21 kilometers into meters. To perform this conversion, think of 21 kilometers as a series of 21 1-kilometer stretches. So if 1 kilometer is equal to 1,000 meters, we can replace each of those 1-kilometer stretches with 1,000 meters. When we do this, we see that 21 kilometers is equal to 21,000 meters. So the meteor will travel 21,000 meters in 7 seconds. Okay, let's try one more example. Here we are told that a car travels at 45 miles per hour, and we want to determine how many minutes it will take to travel 60 miles. To find the time here, we will apply the time formula. However, before we can apply this formula, we must first have matching distance units. Well, the distance is 60 miles, and the speed is 45 miles per hour. Since the distance units do match, we can apply our formula. So we can determine the time by dividing 60 by 45, which simplifies to be 4/3. Now when we apply the time formula, we know that the output is measured in the time units found in the rate. Since the rate uses hours as its time unit, the resulting time will be in hours. From here we must convert 4/3 hours into minutes. To do this, we can replace 1 hour with 60 minutes, and now 4/3 of 60 minutes is equal to 80 minutes. So it will take the car 80 minutes to travel 60 miles. Okay, let's summarize. In this lesson, we learned 3 formulas related to motion. We learned that before we can apply the distance formula, the time units must match. And before we can apply the time formula, the distance units must match. In this lesson, we will learn how to calculate average speeds when a trip consists of 2 or more parts during which the speeds differ. In the example shown here, Jasmine drives 40 miles per hour for part of the trip, and she drives 60 miles per hour for another part. Our goal is to find her average speed for the entire trip. Now, a common mistake here is to find the average speed by adding the two speeds and dividing by 2 to get an average speed of 50 miles per hour. This conclusion is incorrect, and we can see why it is incorrect by examining the following example. Let's say we are making a 1,000-mile trip from point A to point B, and we are driving at a speed of 1 mile per hour. Now, as you can imagine, the trip takes a very long time, but after weeks of driving, we are only 1 mile away from our destination. At that point, we increase our speed and drive 999 miles per hour for the last mile. Now that the trip is over, what was our average speed? Well, if we take the sum of the two speeds and divide by 2, we get an average speed of 500 miles per hour. But that cannot be the average speed. Had the average speed been 500 miles per hour, the entire 1,000-mile trip would have taken only 2 hours, not several weeks. So clearly this is not how we find the average speed. Now, to find the speed during any trip, we simply divide the distance traveled by the travel time. Since this particular trip has 2 distinct parts to it, it might be useful to rewrite the formula to say that the average speed during a trip is equal to the total distance traveled divided by the total travel time. So let's begin by finding the total distance traveled. Now, although the question does not explicitly tell us the total distance traveled, we do have enough information to calculate it. Just be sure to note that there are 2 distances that we need to calculate here: the distance traveled at 40 miles per hour and the distance traveled at 60 miles per hour. To calculate both distances, we will apply the distance formula. Now, the question tells us that Jasmine drives for 2 hours at 40 miles per hour, so the distance is equal to 40 times 2, which is 80. So Jasmine traveled 80 miles at a speed of 40 miles per hour. Jasmine also drives for 3 hours at 60 miles per hour, so the distance traveled during this part of the trip equals 60 times 3, which is 180 miles. At this point, we can add this information to the formula to find the average speed. The total distance traveled equals 80 miles plus 180 miles. Alright, now let's find the total travel time. The question tells us that Jasmine drives for 2 hours at 40 miles per hour, and then she drives for 3 hours at 60 miles per hour. So the total travel time must be 2 hours plus 3 hours. When we simplify this, we get 52. And since the distance is measured in miles, and the time is measured in hours, the average speed is measured in miles per hour. So the average speed for the entire trip is 52 miles per hour. Okay, now let's try another example. Here, Yoshi travels from Townville to Villageton at a speed of 20 miles per hour, and then he returns to Townville at a speed of 80 miles per hour. Our goal is to find Yoshi's average speed for the entire trip, so once again we will apply the average speed formula. To begin, let's find the total distance traveled. Now, the question does not tell us the distance between the 2 towns, and we are not given any information about travel times. So it seems that there is no way to determine the required distance here. Given this, let's let D represent the distance between the 2 towns. This means the total distance traveled will equal D, the distance from Townville to Villageton, plus another D to represent the distance traveled on the return trip. Next, we need to find the total time traveled. Now, please recognize that there are 2 times to calculate here: the time spent traveling at 20 miles per hour and the time spent traveling at 80 miles per hour. Now, since the question does not provide any times, we must calculate these times using the time formula. The time spent traveling at 20 miles per hour will equal D, the distance between the towns, divided by the speed of 20 miles per hour. Similarly, the time spent driving at 80 miles per hour will equal the distance D divided by the speed of 80 miles per hour. Now that we have calculated the 2 separate travel times, the total travel time will equal D over 20, the time spent driving at 20 miles per hour, plus d over 80, the time spent driving at 80 miles per hour. At this point, we need to simplify. First, we can simplify the numerator to be 2d, and next we will rewrite the fractions on the bottom with the same denominators. Now that the denominators are equal, we can combine the fractions to get 5d over 80. Next, to divide by 5d over 80, we will multiply it by the reciprocal, 80 over 5d. At this point, the d's conveniently cancel out to get 160 over 5, which equals an average speed of 32 miles per hour. Notice that although we did not know the distance between the two towns, we were still able to find the average speed of the trip. Okay, let's summarize. In this lesson, we applied the average speed formula, and we learned that it is sometimes necessary to assign variables to solve average speed questions.